Assalamualaikum and hi everybody. Today I will speak about photoelastic experiment. It is an non-destructive test to know the stress distribution on a photoelastic material. So for now I will explain about polariscope. Polariscope is an it is a most general definition. It consists of two polarizer. The polarizer is sandwich a material or an object of interest and allow one to view the changes of polarity of light passing through the material of or an object. Since we are unable to perceive the polarity of light with the naked eye when we projected the light, we are forced to use the polariscope to view the changes of in polarity caused by the temporary birefringence of our photoelastic material. And birefringence is the refraction of light in an anisotropic material in two slightly different directions to form two rays. There are two general classes of polariscope. It is light and dark field. The classification describes the background light emitted through the polariscope in the absence of an object between the polarizer. It can be either parallel or perpendicular. So if it is parallel, it can be said it can produce light field, and if it is perpendicular, it can produce dark field. And a polariscope is constructed, as we know, polariscope is constructed with two polarizer in which perpendicular to the path of light transmitted. The first polarizer is called the analyzer, and the second one is the the first one is called the polarizer, and the second one is called analyzer. And the method in which the polarizer work is quite simple. The unpolarized light enter through the polariscope through the polarizer and then pass through the polarizer, which only allow lights of its orientation though, and this light then pass through the material and which is under observation and experience some changes in polarity in the material, and after that it refracted into the analyzer, and finally it reached the analyzer that will let light of its orientation pass through, and the image can be seen by placing a dark or a light background depending on the specimen that we use. And as we know, both polarizer act as a filter that passively change the light polarization by only allow the certain component wave of certain polarization to pass through, and the birefringent material actively affect the light polarization, letting all light pass but changing its polarization. In addition to the polariscope can be created either linear or circular polarization. As we can see, this is the example of circular polarizer because it has two retarder, or we can say it quarter wave plate. So this, if we have this two polarizer, two quarter plate and a material, these are a way of to illustrate to project a light better for a circular polariscope. And as we know, we have two types of polariscope, linear and circular, that serve separate purposes in the photoelastic method and useful in different situations. The benefit of the circular poroscope, it eliminates the problem of differentiating between the isoclinic and isochromatic, thus lead to no change in isoclinic when the orientation of polariscope changes. As we can see, it can be done due to the quarter wave plate. So although the polarizer change its orientation from 15 to 30 degree or 45 degree, it still give the same colors that projected to the analyzer due to the quarter wave plate, because it has a constant slope between the isoclinic and isochromatic, between the lights itself. And after that, these are the colors that will be projected to the field that can be seen with our naked eyes. And as we can see, the higher it is, the highest one is the red, and then followed by orange, yellow, green, blue, indigo, and violet. It is a rainbow color, as we know. Red has the highest wavelength, however it has lower in terms of frequency, so it has less penetration, but it can go far away. For violet, it is vice versa. So as it goes down, it decrease the wavelength and increase the frequency, so it increase in terms of penetration. For the question, how do you set the polarizer to produce light or dark field? The polarizer can be set into light and dark field depend to the arrangement of the optical axis. For a light field, as we can arrange it to parallel or co-align. We can do a parallel between the polariscope. And then for the dark field, we can arrange the optical axis between the polariscope into perpendicular to each other. And the next question is, how does the ring dynamometer function and provide the calibration factor? The ring dynamometer function, it depends on the tension or stress act on the specimen from the displacement, or we can see that using a strain stress relationship, because we can't measure stress, we can only measure strain. So from the stress strain relationship, by knowing the specimen modulus of elasticity, we can know the stress that has act on the specimen. And how to calibrate the calibration factor is by using precision dead weight, without using lever system that will only cause error in reading. However, when the load required for calibration are very large, proving ring or calibrated test machine should be used. The calibration should be done with the application of load in one direction in X, Y, Z, and the experiment average value should have been taken to avoid experimental error or the machine error. You can see from the average value. If it is too big, maybe we need to have more consideration to have an average great average value, and we can compare with past past experiment. And these are the ring dynamometer, example of ring dynamometer. And the third one, when it is dark field, can you still see light, and why? In dark field, yes, we can still see the light, because dark field arrangement, it will produce image that will be easier to capture and to analyze. We will explain it, why. The dark background of the dark field polyscope ensure that image are not overexposed in the area surrounding the photoelastic material, and the dark background limits the amount of dust or other foreign particle captured by the camera that may be on the polyscope or passing through the polyscope, which will make the analysis less accurate. And for the these are the example of dark field arrangement, and this is the arrangement of light field arrangement. As we can see, dark field arrangement can be seen more clearly and less dust and less particle. And dark field are more likely can be seen clearly rather than light. And the fourth question, with increase of displacement, what do you observe? In this linear polariscope, we can see that when the shift in the stress distribution, and there is a shift in the stress distribution when the displacement increase towards the specimen, because this is a three point bending, we say, I don't know. And when as the displacement increase, we can see that the colors changes to the left side. However, here have a lot of stress at the curvature. You can see at the curvature because it pointed up at the curvature, and there is the point which have the highest stress distributed. And for the fifth question, for the stress sample that you were given, what are your perception on the stress distribution or condition? As we can see, from my observation, the specimen that have two curvature, and at the curvature it has higher stress distribution on it, because it has from the theory side, it has a low in term of thickness, so it has low withstand in term of stress. And these are the CFD for the specimen. As we can see, here are the part that have highest value. And the sixth one, with the cross setting, increase the angle of direction of the analyzer every 15 degree. Observe the changes at the stress model. The stress distribution can be seen more clearly as at the angle of 45 degree when the displacement is fixed, and the angles increase from 0 until 90 with an increment of 15 degrees. As we can see, when the degree is at 90 degree, we cannot see an image at the specimen. These are the and that's all from us. Thank